So today we're going to practice with our parent functions and taking these parent functions and moving them or doing some function transformations. So as we're looking at each of these, we're going to start by just going over what the original equation is for each of these. And once we have the original equation, we'll then go ahead and move them and regraph. So our first function here is a line, and it is a linear function, and our parent equation is y is equal to x. That means it has a y-intercept of 0, and it moves up 1 and 1 to the right. Our next one is a quadratic or a parabola, and our parent function is y is equal to x squared. Once again, it's on 0, so that would be plus 0. Next, we have our absolute value function, and that's going to be y is equal to the absolute value of x. We actually did this in the very beginning, chapter 1 of the year. This one is a cubic function, so our parent function is going to be y is equal to x to the third power. We have another parabola, so our parent function is going to be y is equal to x squared. And finally, we have a square root function, which is y is equal to the square root of x. Okay, now we're going to go ahead and move them. So for this first one here, we are going to move 3 to the left. So that means that this 0 is going to turn into -3. This 2 is going to turn into -1. So that we're making some parallel lines here. This 4 is going to turn into +1. Once you get the main idea of where those are going to be, you can go ahead and create your transformation line. Okay, we're going to go ahead and put our arrows on that line. And now we need to come up with our equation. Now, as you can tell from our equation here, what's happened is the slope has stayed the same. It's still 1, but our intercept, our y-intercept is now up to 3. So when we're moving 3 to the left here, what we're going to actually be doing is raising that y-intercept. So we're going to go ahead and make that shift up. So it's going to be our function y is equal to x plus 3. So when we move to the left 3, we actually are doing a +3. Okay, and then we're going to go ahead and check that on our Desmos to make sure that we have that correct. So once again, our parent function is y is equal to x. And then we're double checking our new transformation function, which is y is equal to x plus 3. And as you can see, we have created that correct parent function. Let's go ahead and move on to our next one. We're moving down 4. So we want to go ahead and have that vertex at -4. This point 2, 4 is going to be at 2, 0. And this point -2, 4 is going to be at -2, 0. And then we're going to go ahead and make that smooth curve for our parabola. Not as smooth as it could be there. And when we're moving down 4, we are going to be subtracting 4 for our equation. So it's going to be y is equal to x squared minus 4. And also that helps you find our y-intercept here has been moved to -4, and we know our plane number is our y-intercept. So once again, our parent function in this case is y is equal to x squared. And we're going to change our function to x squared minus 4 to make sure that it does go down 4. And as you can see, it does. So we are on the right track here. So let's go ahead and move on to our third one. Here we have a flip over the x-axis. So that means that this point that is -2, +2 is going to be -2, -2. This 2, 2 is going to be 2, -2. And etc. So this is going to go here and here. So we're just flipping over those. And then we're going to go ahead and make that flip over the axis. And for our equation, when we're flipping over the x-axis, we are simply going to put a negative on the outside of our absolute value. So our function is going to be y is equal to negative the absolute value of x, because we're going to find how far away it is from 0, and then we're going to make it negative. So let's once again double check. It's always good to use your calculator. So what we have here is the absolute value of x Go. And there's our parent function. And then we're going to flip it by making it negative the absolute value of x. So perfect. Okay, moving on to our next one. We are moving 2 to the right and 1 down. So this point, we're going to go 2 to the right and 1 down. Okay, so here we're going to go 2 to the right and 1 down. So now we're going to go ahead and mimic. So we're bringing that down. We have our half of our parabola going this way and our other half of our parabola coming back up. Okay, so when we move 2 to the right, then we have it inside our absolute value. So that's going to be y equals x. 2 to the right, we are going to have a minus 2. And 1 down, and we're going to put our cube after that, and our 1 down is going to be minus 1. So let's go ahead and double check that one. That's one that can be really tricky because there's so much going on in it. So x cubed looks like this. And then we have x, parentheses for that, x minus 3 cubed. Oh, x minus 2, excuse me, cubed. And as you can see, hang on, x minus, typing is important, 2 cubed. And as you can see right now, it has moved our 2 to the right, and now we want it to move down 1, and we do that on the outside of our set of parentheses to move this point down. So it looks a little funky, but remember those two. So inside that set of parentheses is where we're going to move right or left, and outside that set of parentheses are where we're going to move up or down. Okay, our next one here is move 1 to the left and flip over the x-axis. So 1 to the left is going to be right here for my vertex, and then we're going to flip it over the x-axis. So it's going to go ahead and look like this. Okay, so as we're looking at our y is equal to, our 1 to the left is inside our set of parentheses. So that's going to be our x, and we're moving 1 to the left. So our 1 to the left is going to be plus 1, and then we're flipping it, and so that flip is actually going to be a negative outside our set of parentheses, and don't forget your square. So we have, for our parent function, y is equal to x squared, and then we're going to move this to a square as well, and inside our set of parentheses is going to be that plus 1 because we're moving it to the left. And then we want to flip it over, and we flip it over by making that outside negative. So lots of little things, but since you're able to use your notes, you can keep your kind of rules next to you of how each of them transforms. Okay, we're going to move up 3 and 5 to the left. So this point is going to go up 3 and 5 to the left. This point is going to go up 3 and 5 to the left. Okay, and then we can make that smooth curve. And the thing about square root functions is it does have a starting point. So as we are moving our 5 to the left, we are going to have our square root, and inside our square root, we're going to have our plus 5. And then outside of our square root, to move it up, we're going to have a plus 3. And as you're typing this in, you have to be careful. It's hard to read. Let me go ahead and write it here. Y is equal to, oh, that's an x, the square root of x plus 5. And then make sure you're outside of that square root for that plus 3. Okay, so let's check that last one on here. And our original function is the square root of x. And then as we're changing that, we have the square root of x plus 5. And as you can see, that's moved it to the left. And then we're moving a right click out. And then we want to bring it up 5. So we're going to go plus 3. Okay, and there we have it, ladies and gentlemen, our transformations, some easy, some a little bit harder, and it just takes practice. And make sure you're checking on Desmos every single time, because sometimes the pluses and the minuses can get confusing.